Hey everybody, Mr. Piercy here. What we're going to be discussing in today's lesson are two things. We're going to be identifying types of lines in figures, and we're also going to start identifying special types of angles in figures. So let me make sure that you can see all of the vocabulary terms here. What I want you to do is at this time pause the video and copy down the vocabulary terms that you need here, and when you're done, press play again. Okay, so you have the first four definitions. I know that there's more that follow this, but you should have the first four definitions copied down, and I want to explain a little bit about these terms. The images that we have, and there's one more that you can't see on the screen right now, but I'll show you here in a second when we get there. Here, in my experience, I can ask any high school geometry teacher on the very first, or high school geometry student, I should say, I can ask any student on the very first day of school, hey, what's the definition of parallel lines? And everybody will say, well, they're two lines that don't intersect. Now, in high school geometry, that is partly true. Unfortunately, part of our defined characteristics of our terms, we have more than one kind of line that won't intersect. So we have to differentiate them a little bit. And what we think of as true parallel lines, lines that don't intersect, those lines are going to be considered coplanar. Whereas skew lines are non-coplanar. So parallel lines, what we normally think of, they have to be on the same plane, or you must be able to create a plane between the points that make up the lines. With skew lines, it's not really possible to do. Now, let me illustrate here. This image here is what I'm referring to parallel lines, not so much because I don't think you know what they look like, but particularly because I want you to recognize the symbology that geometry uses. These arrows indicate, that's the way that geometry indicates that those lines are parallel to each other. So everything that has a single arrow on it will be parallel to everything else that has a single arrow on it. And here, the ones that have double arrows, they're just using two arrows to differentiate from the one arrow parallel lines. Now, what about skew lines? Skew lines are non-coplanar lines that don't intersect. Now, at this point, I really want you guys to burn this into your memory. Make a note to yourself on your handout, something, because I guarantee you, you're going to be asked this question again at some point, and some of you will remember and be fine, and others are going to forget. There's a difference between parallel lines and skew lines. If you do not distinguish the difference between coplanar being parallel and non-coplanar being skew, it will cost you points on future assessments. So make sure you distinguish those now to yourselves in some way, so that way you'll be able to remember them and say, oh, I have to remember this for a test or a quiz. Now, skew lines are going to be lines that don't intersect, however, they're not going to sit on the same plane. So that's what this image here is talking about. It's showing you, well, these lines are skew. Now you can see between points A and B and say E and F at the bottom, those two lines definitely don't intersect each other, and there's no way that I could create a flat surface that contained all 4 points. So that is why they are skew. They're not going to be on the same plane no matter what we try to do, and they still won't intersect. Now parallel planes, those are about as basic as they can be. There's no such thing as skew planes. Parallel planes are literally just two planes that never intersect each other. So now let's see here. Let me pick a slightly darker color for this next part. Next thing we're talking about is a transversal line. A transversal line is a type of line, or rather it's not a type of line, it's just a name that's given to a line that happens to cross two or more other lines. So this red line that you see in the image is acting as a transversal line. It is crossing line A and line B. And in so doing, it's creating angles. We have angle 1, 2, 3, and 4 here, 5, 6, 7, and 8 here. Now, this line, this new line that we're talking about, it's creating these angles, and these angles have names, and that's what we're going to see. We're going to talk about those in more detail later on. But a transversal line is just anything that really just crosses more than one line. So I don't want to do that. Let me just go here. If I extend, let's say I extended line A out here, and I extended this out, and let's say we put in another line like this. We have 4 lines where each line is crossing at least 2 different points. So let's call this line C. All 4 of those lines could be a transversal line to the other 2. So for instance, let's call this one here D. Line D is transversal to line A and B. Same thing with line C. It is transversal to line A and B. Now line A is transversal to lines C and D. Same thing with B. It would be transversal to lines C and D. So every line could be considered a transversal line as long as it crosses 2 or more other lines. So here are the remaining vocabulary terms on the front of your handout. At this time, pause the video and copy down what you need to, and when you're done, hit play and listen to the further explanation. Okay, so hopefully you have the vocabulary terms down. We're going to talk more about the first 3, corresponding alternative, interior, alternative exterior. The one thing that I want to mention on this bottom one here for now, where it says consecutive interior angles, and in parentheses I have same side interior angles. Those are 2 commonly used names to represent the same thing. So if you picked up a geometry book that was written in 1 year versus a geometry book that was written a few years later, or maybe from one state to another state, consecutive interior angles, same side interior angles, you have almost an equal chance of seeing those things called one or the other. So I want to make sure that you guys understand if I say consecutive interior or same side interior, I'm only talking about the same thing. Now we'll talk about these in a little more detail shortly. But let's take a look at our first example here. The first thing we're trying to do is identify, can you see lines in the figures that fit certain criteria? So here we have, depending on how you want to say it, you can call it a pentagonal prism or a pentagonal prism because the base of the prism is a pentagon. Now because it's a prism, it does have certain characteristics. All of the edges that connect the bases together, meaning like segment AF, segment EJ, they're all going to be perpendicular to the segments that make up the bases. So that's one of the characteristics about a type of prism like this. But let's take a look and see what it's asking us to identify. We have these 4 things that it wants us to look and identify in the figure. What are the lines or lines that are parallel to line AF and contain point E? Well, I'm not going to be able to fit all of this on the screen here, but we can kind of look at this here. So let's look at AF. So here's AF, and we want to know what are all the ones that are going to be parallel to it. Well, all the ones that look like they would be parallel would be like E. Ooh, you can't really see that very well. Let me pick a bright color. Maybe yellow will work. So we have that one, that one, that one, that one. All of those really look like they're going to be parallel to EF, but only one of them will actually go through point E the way we're being asked to. Now, some of you may wonder, well, why am I bothering to identify all four line segments or lines that could be parallel to the given line if only one of them is the answer. And I'll explain more about that here very shortly. But moving on, here, let's take a look at B. What are lines that are skew? Okay, now remember, there are lines that are not going to form a flat surface, so they're not coplanar, and they're not going to intersect. Well, actually, there's quite a few of them. So make sure you get these lines copied down in your handout. But the only one that's going to go through point E also is just going to be line DE. So the next one, something that here, what are the lines that are going to be perpendicular? Well, same thing. There's actually quite a few, but because we're only looking for one that goes to a particular point, there's only one that we can refer to. Now, again, you may ask yourself, well, why would you mention the other lines if there's really only one answer that we want to see here? And again, just bear with me for the time being, and I'll explain why here soon. So the last one, find a plane that's parallel to FGH and contains point E. Well, that would be, for instance, plane ABC. Now, right underneath that, you have these four questions that I would like you to attempt answering on your own before you listen to my answers. So at this point, go ahead and pause the video, answer these four questions, and when you're done, hit play. So for question number one, what is a line that is parallel to line MN and contains point J? Well, that would be line JL. What is a line that is skewed to line MN and contains point J? Well, that would be line KJ or JK. You could write it the other way around. 3 is going to be line JN. And finally, 4, the plane that we're going to be looking for would be plane JKL. Now, looking here, this is where I kind of was telling you to just be patient with me a bit for questions or for parts A and C, where we listed all of the lines that were both parallel or perpendicular to the given line, but it had to go through a specific point, and that's coming to this. Well, at those points, you're like, well, it's probably pretty obvious that there's only one line that could be the answer. And that's exactly what they're referring to here in the parallel postulate. Remember, a postulate is just something that you can accept to be true. So I don't think that I really had to explain a whole lot to say, well, there's only one line that could be parallel to the given line and go through point E at the same time. Same thing here. There is only one line that could be perpendicular to the given line and still go through point E at the same time. Now, the last thing I want to mention here about these, and this is a critique that I personally have of pretty much every geometry curriculum that I've ever used. This here that says postulate 13 and postulate 14, there's no such thing as a postulate 13 and a postulate 14. It's just the thing that curriculum writers or textbook writers happen to do. In the curriculum where this material is pulled from, it simply says this is the 13th and 14th postulate that have been presented to students. So there isn't really such a thing as a postulate 13 or a postulate 14. It is simply the 13th and 14th postulates that have been presented. Thinking of them as the parallel postulate and the perpendicular postulate would be a much better way of thinking of these two things rather than postulate 13 and 14. So the last thing that we're going to kind of take a look at in this video, and then I think we'll take a break, is going to be, well, can you look at these things and answer the questions that they're asking you to identify? Now, at this point, I am going to ask you to just remind yourselves that in geometry, you can't make assumptions. You have to either be able to make a conclusion based on information that's given to you, where we kind of using a little bit of deductive reasoning, or maybe you're relying on a pattern that you're making a conjecture with, you're using some inductive reasoning. So you can't just say something is because it looks that way. Now, keeping in mind that information, can we name a pair of parallel lines in the figure? Now, they're not outright saying that, hey, guys, this line is parallel to this line. However, they are giving me something that will allow me to justify that the lines are parallel to each other. Those arrows say yes, those are parallel to each other. A, B, and C, D will be parallel. So can we next determine what about something perpendicular to something else? Can I name a pair of perpendicular lines? And I absolutely can. Even though they're not telling me directly, they're using the symbols to show, hey, we have a right angle symbol there. So yes, I can conclude AB is perpendicular to AC. Now pay attention to the symbols that we have here. The two vertical lines are saying AB is parallel to CD, and that upside down T looking thing is the symbol that we use for perpendicular. So for part C, is AB perpendicular to BC? Well, unfortunately, no, it is not. The perpendicular postulate says it can only go through one point and still be perpendicular to the line. So no, unfortunately, this one's not going to be that way. And there's nothing in the diagram that allows us to draw that conclusion anyway. Now here's the example that I would like you guys to work out. Now the question is asking you, it's just using the diagram that we see here. Can you use the perpendicular postulate to show that AC is perpendicular to CD? So at this point, this is a question I want you guys to think about it on your own. So pause the video and come up with the solution, and when you have your answer, come back and check to see how you did. Okay, now this is a question that I really actually like a lot because it makes you think not just about what is a perpendicular postulate, but how can I show these two things might or might not be perpendicular? Because it's not so, at its heart, this is really just a yes or no question, but here's one of my favorite things in a question: explain. If you can't tell me why something is your answer, well, it's not really a good enough answer. You might guess correct once in a while, but understanding comes from when you can actually explain something. Okay, so here is my answer. I actually am splitting myself into two parts here. Technically, using the the perpendicular postulate, no, you cannot say, there it is. No, you cannot say that they're perpendicular using the perpendicular postulate. However, you can actually justify that those are perpendicular lines, because if the first two lines, A, B, and CD, are parallel to each other, and at the same time AB is perpendicular to AC, then we could be able to conclude that AB must also be perpendicular, that AC must also be perpendicular to CD. So we can use a little bit of deductive reasoning to say, yes, we can do it that way. But technically, because the question did say, well, can you use it using the perpendicular postulate? Unfortunately, no, not that way. But yeah, you could actually say that those are perpendicular to each other. So we're going to go ahead and take a pause here. I know that there's more information, but we're going to take a pause here. So again, any questions that you may have had or thoughts you want to ask or share, make sure you email them to me. Leave a comment in the section of the Google Classroom. And everybody start talking to everybody else, and that means me too. So if you have questions, let me know. But until next time, take care. There will be a follow-up video for this for the remainder of the notes. But thanks for watching, guys, and see you soon.